Hey class, good night. Welcome to another session. It's a minute past 8 and we're here to continue discussion on operations management. I hope you guys were happy with your results of the midterm. I was happy with the results myself. And if you have any questions or if you want to clarify anything, feel free to let me know. Okay, so in the previous session, we have been talking about quality management, right? And so things that are pending related to quality management, we're discussing the 7 tools that are used in making sure that we have total quality in everything we do in the organization. So it doesn't matter if it's a service or if we are working towards producing a product or delivering a product to the customer, it needs to be delivered with total quality in mind. And so when we speak about total quality, we're talking about minimizing the number of defects that are available or that are provided to the customer. So we don't want any defects in our operation, right? Because the minute we have defects, then there is a cost associated to that. So we have established that. And so we're going to look at the total quality management tools. There are 7, okay, of these tools. And we'll briefly look at them. And then one of those will be your assignment 2, okay? And I'll give more details later on about that assignment. But let me go ahead and share my screen real quickly here, okay? And so the tools related to total quality management, there are 7 of them. We have the check sheet, scatter diagram, cause and effect diagram, Pareto chart, the flow chart, histogram, and the statistical process control chart. So there are 7 of these total quality management tools. Real simple to use. If you encounter them, you will be familiar and you will know how to use them, okay? The check sheet is a simple document where you pretty much keep a tally of defects in the process, right? So you have a chart that you create and you have the data, and based on the various or the process that has been established, you keep a tally of anytime you encounter a defect. So it basically allows you then to keep track of what's happening in the operation and keep track of any situations that can cause a defect. So by having this check sheet, you can then plot it into a diagram and see or see a pattern, right? An example here, maybe you notice that there are too many defects in the 1st hour, the 7th hour, and 8th hour. So it's a matter of investigating. Maybe it's because the shift is just starting, and so people are just coming into the workplace and they're trying to start their day, and maybe they're not too alert, and maybe to the later part of the day they're already trying to rush things because they want to go home, they want to close early. Those kind of situations, then you will be able to make an inference, right, based on the data that you collect using a check sheet. Right? So that's the first tool that we have, right? And it can be fairly simple. Just keep a tally, right? Keep a count of how many times there is defect in the process. The second one is the scatter diagram, okay? And the scatter diagram, we're trying to graph or create a depiction to see if a particular variable or particular measure in our operation, if that is affected by another variable, right? So if you notice in this case, productivity decreases as absenteeism increases, right? And this chart that we see here. And so we can measure, with the number of people that are absent. If it is lower, we can visually see that the productivity increases because there are more people in the ground working, right? And so the scatter diagram, allows us then to create this graph of relationship between variables. So you have a variable that influences another variable, okay? The third one is the cause and effect diagram, also called the fishbone diagram or Ishikawa diagram. It tells us, or it allows us to pretty much take a particular problem at hand that you want to investigate, and you dissect that problem into various possible reasons as to why that problem exists in the first place. And so it's standardized to look at materials, to look at methods, to look at manpower, to look at machinery. And so looking at each of these areas in the operation, then you try to determine, okay, under materials, for example, what would be causing the problem that we have at hand, right? Maybe the materials that we're using are substandard. Maybe they're not arriving early, things like those, right? You would then, of course, these tools are used with a team to try to brainstorm what's going on with the operation and what's the reason that you have that problem in the first place. So similarly with machinery, maybe the issue is the machinery, maybe the issue has to do with equipment that exists in the operation that is too old, that maybe needs to be serviced a lot, and so there's a lot of downtime in the servicing, and so that causes some effect. So using the cause and effect diagram, you're trying then to identify what is causing that effect, what's causing that outcome in the first place. Moving on, we have then the Pareto chart. The Pareto chart is pretty much just a bar graph, right? But the bar graph, it has an order of frequency from the highest to the lowest, right? You have a depiction of what problems exist or what defects exist. And so that allows you to visually right away identify what the most important thing that you need to tackle in the operation or streamline the operation to make sure that it is delivering quality to our customer. Okay, so it's pretty simple diagram, just a bar graph out of a frequency table that has the highest frequency down to the lowest frequency there. And we have the flow chart, also called the process diagram, because you're able to visually depict what's happening in the entire process. And we will mention the flow chart in a subsequent topic about process management. And so you can see visually the depiction, right? From one particular part of the operation, which normally are depicted in rectangles, and it finds a diamond. That means there's a decision factor there. Would you continue with the following process, or maybe based on that condition, you then go and you do something else? Right, so that's the flow chart. Okay, the sixth one, we have the histogram, a distribution. So you have also a frequency table, but you're looking at based on the histogram, trying to find what is the average, right? And trying to make sure that anything that is being produced falls within a certain margin of error, okay? So pretty much it's trying to, as long as it falls around that average in the distribution, in this case, then it means that it's doing okay. Anything that's falling outside to the right or to the left of normally a bell-shaped distribution, then you see maybe it's skewing to the left or skewing to the right. There is something in that area that you need to investigate further. I need to maybe do some modifications so that it aligns to total quality management. And finally, we'll talk about the statistical process control chart. It's a simple chart, and there is a target value, right? Of course, there are certain parameters in terms of, okay, there may be some margin of error. So the process establishes there is an upper control limit and there's a lower control limit, right? So a plus minus margin of error of the target value. And so it's plotted and over time looked at and after inspection to make sure that the process is falling within those control limits. If it falls outside those control limits, then it's time to inspect the process or try to figure out what's happening or investigate further to align it and bring it down back to the control limit where it should be. Okay. You probably have seen or have can relate to a process control chart if you have been to the doctor, have seen someone get hospitalized, right? Nurses come and check every time your temperature and check your pressure, right? And they plotted that down in a chart. And so it cannot go higher than certain limits, right? Or lower than a certain limit. So they keep track of the person's health there. Okay, any question regarding these 7 tools that I wanted to briefly touch on before we move into the other lesson? Anybody have any question? Would like to mention anything? Let me bring my class here.
Mr. Archuleta, will we get into them how to proceed and carry out these charts, or we just need to know the meanings and what they are used for?
Yes, you that'll be part of the assignment hierarchy so that you can practice and use them. But let me go back and show you the one that I would want you to be familiar with is the cause and effect diagram, right? Because we can take a problem, right? Let's say you're having an issue with class, right? So you can take that as an example. So I have an issue with our online classes. So that would be the effect, right? And maybe you need to specify what's the issue really, okay? Yes, the cause and effect diagram, correct. And so in looking at that cause and effect diagram, right, we already know what's the effect. Issues trying to log in, right? So we determine, okay, is it an issue that's related to people? Is it an issue related to the material, right? Is it an issue related to machinery, right? Or is it an issue related to the methods in which we're doing it, right? So we would then go and brainstorm and try to figure out, okay, out of maybe methods, for example, okay, we start to break it down into subcategories and figure out, okay, what falls under methods, okay? Maybe is it the system that is used, right? Or are you accessing it using the link? Are you accessing it using the web version, or do you have installed the application on your computer? Or you're using Zoom, right? You're using what's the operating system you're using and so forth. So it's a matter of then brainstorming and trying to find and pinpoint the root cause, right? Or all the possible causes of that problem that you have at hand. Okay?
Okay, thank you. Thank you, Mr. Chair.
Okay. So here's an example of that cause and effect diagram. I'll bit, right? So let me, can you guys see what's the effect here, the problem, right? Someone that's having an issue, right? They're trying to figure out, okay, how can I improve in hitting free throws, right? I'm missing too many free throws during my basketball game, right? So you can start to then look at, maybe it's the material, right? Material referring, maybe it's the ball, right? Maybe the ball doesn't have a good grip. Maybe the air pressure in the ball is too low. Maybe we need to add more pressure. Maybe the ball is too small, or maybe the ball is too big, right? Or maybe the ball is defective in some way, right? So that would fall under material, for example, right? Who could look also at method, okay, or method. Okay, how do you go about and doing your shooting, right? Do you aim first? Do you bend your knees, right? How do you position yourself? How do you follow through when you shoot the ball, right? That would be the method. Then we have the manpower. Okay, now you're trying to figure out, okay, is the problem the person, right? Is the problem the person not consistent in training? Is the person not concentrated? Is the person not motivated to practice, right? Those type of things can impact the problem at hand here. Or maybe in looking at machinery, maybe it's the hoop and the backboard. Maybe it's the height is not adequate, right? Or the rim size is too small, or it's kind of crooked there, right? So those things, right? Then by doing a diagram like this, you would be able to say, well, okay, all these are possible causes of why someone would miss a free throw, right? As an example there. Make sense? Is it clear?
It does, yeah. Yeah, it does make sense.
Okay, okay, thank you. And so looking at then a flow chart, right, which I was mentioning earlier, then in this case, the flow chart here has all the various steps someone takes to do an MRI, right? And so just to simplify it, you go from process one, from the beginning, you go to following each step, right? Go to step 2, then it follows to step 3, then it follows to step 4, step 5, step 6. So there is a step 7, which is a condition, right? And so in this condition, if the person is satisfied, then they can choose between 8, right, or 9, depending on what it is, or they can go back and repeat the process if they're not satisfied in this case, right? And so it's similar to the networks that we drew, right? When we were talking about project management, and we have the different node to, right? Activity on node or activity on arrow type of diagram, right? Almost similar, right? Except that here we're just using a flow chart. Okay, so one of the things that we can use in trying to manage quality is to inspect, right? And so we can inspect to make sure that there are no issues in the process, right? That there are no issues with the there are no issues with the particular products that we want to provide to the customer. Because at the end of the day, the quality, there are 2 types of quality that we want to look at. One of them is quality in conformity, quality meaning that the products will conform to whatever specifications we have to be able to produce it, right? And the other one is quality in the eyes of the beholder, in the eyes of the customer, right? The customer will see that they have received value, right? And so that it is not, or that it is providing value to the customer and it's not costing the operation more than what it should, right? And so when we do not focus in quality, of course, the cost to our operation increases and we spend up, we waste more resources than what we should, right? And so we should inspect, of course, whenever we're receiving supplies from our suppliers, right? Before it enters the plant and before it's used in operation, there needs to be some type of inspection there, right? So once we receive those, we have to do that inspection, right? We need to do inspection during the production, right? Before it's irreversible, before you can say, well, it's too late, we have to scrap this thing, right? You have to do inspections then, right? Or during the step-by-step production process, right? As you go from one particular in a production, when you go from one work cell to another work cell, you have to be doing inspection so that if during that process the product needs to be fixed, right? If there's any defect, then you just send it back to the previous process and then that gets rectified and then it can continue the process, right? It can also happen, right? Once the production is complete, right? So the final inspection before it's packaged, at a point when the customer is about to receive it or before you ship it out, you do a final inspection to make sure that you're shipping the actual item that the customer ordered. And when it's going to be delivered to the customer, right, at the customer point, touch point, you also can do an inspection to make sure that, okay, it conforms to the quality that is desired and it's giving the value that it was intended to give.